In this video, we're going to go over how to multiply with rationals. When we do this, it's going to be more advanced than when we've dealt previously with multiplying fractions, but your rules are still going to remain the same. In order to multiply fractions, you're going to multiply straight across. You're going to take your numerator times your numerator, and your denominator times your denominator. So to refresh your minds, looking at this example here, we have a 2/7 times a 3/4. How are we going to multiply those two fractions? We're going to simply multiply the numerators. So I'm going to take a 2 times a 3, and that's going to become my new numerator. And I'm going to take a 7 times the 4, that becomes my new denominator. 2 times 3 is 6, and 7 times 4 is 28. Now we have to simplify that fraction. In this particular one, they are both divisible by 2, so I can divide both sides by 2. I didn't get a very good divide sign there. There we go. So 6 divided by 2 is going to give me a 3, and 28 divided by 2 is going to give me a 14. So there was my final answer, and that was how we multiplied with fractions that were just numbers. But we are more advanced than that, and we're going to have to start dealing with some variables. The rules are not going to change. They're going to stay the same as when we worked with numerical fractions. So let's look at a more advanced example. So here, when you work on your homework for this, your directions are going to be to multiply each and then state your excluded values. So first we have to multiply, then we're going to find our excluded values. So to multiply these, I'm going to go ahead and take numerator times numerator. So I take a 7x times the 6, and I take the 4 times the 10. 7x times 6 is going to be a 42x, and a 4 times 10 is a 40. I can simplify these by dividing top and bottom by 2, which is going to give me a 21x over 20. And I cannot simplify any further. Now I have to find my excluded values. So your excluded values come from your original denominators. I had a 4. Well, if I set that equal to 0, what? That's not going to happen. And then I had a 10. If I set that equal to 0, again, what? That's not going to happen. So I have no excluded values. I can choose any number for my variable, and it's not going to blow up the world. So here is my final answer. I have my simplified answer of a 21x over 20, and I'm stating that there are no excluded values. Let's look at another example. So here we have a 10n over a 7n cubed being multiplied by a 4n over a 6n squared. So from here, we're going to do the same thing. We're going to multiply these two fractions by taking numerator times numerator, so 10n times 4n, and taking denominator times denominator, 7n cubed times a 6n squared. Now I'm going to go ahead and simplify. So 10 times 4 gives me a 40, and an n times n gives me an n squared. And in the denominator, I have a 7 times 6, which is 42, and an n cubed times an n squared, which gives us an n to the 5th. So now I need to simplify. And again, using exponent properties here, I'm going to have a 40 over 42. They're both divisible by 2, so that's going to give me a 20 and a 21. And an n squared divided by an n to the 5th, that's going to leave an n cubed in the denominator. So from here, now I have to find my excluded values. They come from our original denominator. So I'm going to take the 7n cubed, and I'm going to set it equal to 0, and I'm going to take the 6n squared and set it equal to 0. Now I have to solve. Here I'm going to divide both sides by 7. I get an n cubed is equal to 0. take the cube root of both sides, I get an n is equal to 0. In the second one, divide both sides by 6. I get an n squared is equal to 0. Square root both sides. N is equal to 0. So in this instance, I got the same answer. Those are my excluded values. So my excluded value is that n is not allowed to equal 0. And here is my final answer. Let's look at another example. So here, we're getting to be a little bit more complicated. We have more stuff going on here. So this one, we have a 3x plus 7 times a 5x plus 4 all over 5x plus 4 being multiplied by an x plus 8 over a 4 times a 3x plus 7. Our rules still have not changed, even though we have more going on in both of these fractions. I'm still going to take numerator times numerator, so I'm taking my 3x plus 7 and my 5x plus 4, and I'm going to multiply it by that x plus 8. And all of that is over the 5x plus 4. And I'm going to multiply it by the 4, and I'm going to multiply it by the 3x plus 7. So now that we've done that, we can look to simplify. So if we notice here, we have a 5x plus 4 on the top and the bottom. Those divide to equal 1. We have a 3x plus 7 on the top and a 3x plus 7 in the denominator. So they can divide to equal 1. We can cross them out. So I'm left with an x plus 8 over a 4. So there's my simplified answer for the multiplication of those two fractions. Now I have to set my denominators equal to 0. Find my excluded values. So a 5x plus 4 equal to 0. To get x by itself, I'm going to subtract the 4 to both sides. That's going to leave me with a 5x is equal to negative 4. To get x by itself, I'm going to divide by 5 on both sides. So I get an excluded value of x is equal to negative 4/5. So that is one of my excluded values. I'm going to write it over here. And now I need to find my other excluded value. I need to work with my other denominator. And I ran out of room here, so since we've already wrote down our answer, I'm going to go ahead and erase this to make room so that we have room to work our next denominator. So now I have to set the other denominator, that 4 times the 3x plus 7 equal to 0. So here, I can go ahead and divide both sides by 4. That's going to leave me with a 3x plus 7 is equal to 0. Now I'm still trying to get x by itself, so I'm going to subtract 7 from both sides. That's going to leave me with a 3x is equal to negative 7. And I have to get x by itself, so now I'm going to divide both sides by 3. And I arrive at x is equal to negative 7/3. So that is my other excluded value. So I have my final answer of x plus 8 over 4 with my two excluded values, and that x cannot equal negative 4/5 and x cannot equal negative 7/3. Let's look at another example. So in this example, we have a 4n times an n plus 9 over an 8n times an n plus 1, all being multiplied by a 20 times n plus 1 over a 10n. Same rules apply. We're going to take numerator times numerator, denominator times denominator. I haven't really been using color coding, so let's use this example to go ahead and color code. I'm going to take this guy, and I'm going to multiply it by this guy. So I have a 4n and an n plus 9, and I have my 20 and my n plus 1. That is all in my numerator. And now I'm going to take denominator times denominator. So I'm going to take all of this guy, and I'm going to multiply him by this guy over here. So I have an 8n and an n plus 1. Change color again. And I have a 10n. Now I need to look to make any cancelizations to simplify. So here I have an n plus 1 at the top and an n plus 1 at the bottom. They're going to cancel each other out. Now there are several ways we can go about simplifying here. I am going to do it one fraction at a time. So if I look at this guy, let's cancel out what else we can cancel out. We have an n at the top and an n at the bottom that we can cancel out. So then now, let's go ahead and take a look at, we have a 4/8. So if you remember simplifying fractions, a 4/8 simplifies to a 1/2 because both top and bottom are divisible by 4. So I can replace that top 4 with a 1 and that bottom 8 with a 2. And then if I look over here, I have a 20/10. Well, 20/10, well, that's a 2. So the 10's going to cancel out, the 20's going to cancel out, and be left with a 2. So let's put our numerator back together. Who is still alive? I have a 1, I have an n plus 9, I have a 2, and I have nobody else. In the denominator, who is still alive? I have a 2, and I have an n. So now I have to look to see what I can do to simplify from here. So again, I can look to simplify. I have a 2 and a 2 that can cancel each other out. So now I am left with my simplified answer of a 1 times, I don't need to write, so I have an n plus 9 in the numerator and an n in the denominator. So there's my simplified part. Now I still have to find my excluded values, so that means I have to set all of my original denominators. So my excluded values, first I'm going to check the 8n and the n plus 1 is equal to 0. So here I have two things being multiplied together to equal 0. So I set the 8n equal to 0, and I set the n plus 1 equal to 0, and solve from there. So here I divide by 8, and I get an n is equal to 0. The other guy, I'm going to subtract a 1 from both sides, and I'm going to get an n is equal to -1. So these are both excluded values, so I need to write those down. An n cannot equal 0, and n cannot equal -1, and then I need to erase to make some room to check my other denominator. My other denominator was a 10n, so I need to set a 10n equal to 0. So to solve for n, I'm going to divide both sides by 10. And once again, I arrive at an n equals 0. We already wrote that down over here, so I don't need to write it down again. So we have our final answer, our simplified expression, an n plus 9 over n, and our excluded values. N cannot equal 0, and n is also not allowed to equal -1. Let's look at another example. So here we have 56n cubed plus 48n squared all over 7n being multiplied by 9 over 56n cubed plus 48n squared. Again, the process doesn't change. We're still multiplying fractions, so we're still going to take numerator times numerator. So I'm taking all of this guy, and I'm going to multiply him by this guy. The order in which we multiply doesn't matter, so I'm going to write the 9 first because we're used to looking at things that look like that more than we are looking at it the other way. So we have that guy in the numerator. Now we're going to take our denominator times our denominator. So we have a 7n times a 56n cubed plus a 48n squared. So now that we have that, we can look to cancel. We have a 56n cubed plus 48n squared on the top and bottom. They're going to divide to equal 1, so we can cancel them out, leaving me with my simplified answer of 9 over 7n. Now all that's left to do is find the excluded value. So my excluded value comes from my original denominators. So 7n is equal to 0. Divide both sides by 7. And you're going to get that n is equal to 0. That is one of our excluded values. So I'm going to write that down over there. And then we have to set the other denominator, 56n cubed plus a 48n squared equal to 0, and solve from there. So here I need to look to factor. I can factor out an 8n squared, and that is going to leave me with a 7n plus 6. Now I have two things equal to 0, two things being multiplied together to equal 0. So I can go ahead and set both of them equal to 0 and solve. So this first one, 8n squared equals 0. Divide both sides by 8. You get an n squared is equal to 0. And then you're going to take the square root of both sides, and you're going to arrive at an excluded value of n equals 0. Well, we already wrote that guy down here, so I don't have to write him down a second time. Now I have to check the other one. I still have to check this guy right here. So I'm going to have to do some erasing to make some room. So I'm going to erase up here, give us some room. So now we need to check a 7n plus 6 equal to 0. Work on getting n by itself. I'm going to subtract 6 to both sides. I get a 7n is equal to a negative 6. And then I'm going to have to divide both sides by 7. So I get, make some more room there. I get that an n is equal to negative 6/7. So that is my other excluded value. So final answer, I get 9 over 7n, and my two excluded values, n cannot equal 0, and n cannot equal negative 6/7. Let's look at another example. So looking at this one, again, our rules and our process isn't going to change. I'm going to take numerator times numerator. So I have a 3 times a 49p squared plus 49p. And in the denominator, I have a 7p times a 70p plus 70. Now I want to look to make some cancellations. Well, right now, it doesn't appear that we have any, but we do have some things we can factor. So we had a 49p squared plus 49p. I can factor out a 49p. That is going to leave me with a p plus 1. So I can replace this whole thing right here, I can replace with its factored form right here. So let's go ahead and do that. So in the numerator I have a 3. Now I have a times a 49p, and I also have a p plus 1. All of that's in my numerator. Now I need to look to see if we can factor the denominator. We have a 70p plus 70. Here I can factor out a 70, which is going to leave me with a p plus 1. So using the same thing, I can replace this 70p plus 70 with its factored form. So let's go ahead and do that. So I still have my 7p, and now I have a 70 and a p plus 1. So now from here, I can look to make some cancellations. I have a p plus 1 divided by a p plus 1 divides to equal a 1, so we can cancel those out. Now, if we look closely, we have some other things that we can simplify. Right here, I have a 49 divided by 7. Well, that's going to leave just a 7 in the top. So he would cancel and he would become a 7. So now let's make some room here. We already did our factoring. So now we have a 3 and a 7 now. And the p plus 1 died, so we're left with just a 3 times the 7, but we still have that little p right there. So there is my numerator. And in the denominator, I have a 70 and a p. So now I'm going to look to make some cancellations again. Well, here I have a p at the top and a p at the bottom. So now I'm just left with 7 times the 3 in the top over a 70. So 7 times 3 is 21 over 70. And I can simplify that fraction by dividing top and bottom by 7. And I'm going to get a 3 over 10 for my simplified answer. Now I just have to find my excluded values. So I know my simplified answer is a 3 over 10. I'm going to leave that over here so I can erase and make space to find our excluded values. Your excluded values, again, they're still coming from the denominators in your original equations or your original expressions. So I have a 70p plus 70 that I need to set equal to 0. Here I can factor out a 70, which we already did. That's a p plus 1. So now I have two things multiplied together to equal 0. So you set both of them equal to 0. 70 equals to 0. Well, that's never going to happen. Or the other thing we could have done, if we didn't want to use the zero product property, was we could have divided both sides by 70. Either way is a valid approach. So now we're left with a p plus 1 is equal to 0. We solve for p by subtracting 1. And I get an excluded value of p is equal to negative 1. So we know p cannot equal negative 1. Then I have to check my other denominator. So let's go ahead and erase so that we can make room to do some more work. Now I need to set the 7p equal to 0. Divide both sides by 7. And I arrive at my other excluded value of p cannot equal 0. So I have my final answer of 3/10. P cannot equal negative 1 and p cannot equal 0. And there's our answer.